Today's lesson is our second day on section 5.5, factoring polynomials. In our last lesson, we learned how to factor a sum and difference of two cubes. Please look at Canvas to find the examples that we did in class. Today, we're going to spend a second day over factoring, and our lesson is going to be on factoring polynomials of quadratic form. Quadratic form, of course, is ax squared plus bx plus c. And equations in that form can be solved by factoring or the quadratic formula. To be of quadratic form, if the middle term's exponent is 1/2 the first term's exponent, any trinomial of this form with a constant as the third term is considered to be of quadratic form. And U substitution is one way we can go about factoring. We can also factor directly. So I'm going to show you both methods here in our first example. So as you look at our first example below, you notice x to the fourth minus 29x squared plus 100 equals 0. And notice the first term, the middle term's exponent of 2 is half the first term's exponent. What that means is I can actually rewrite our equation to be of quadratic form. I'm going to rewrite the first term as x squared raised to the second minus 29 times x squared plus 100 equals 0, since it's an equation. And x squared is going to be what I let u equal. And what I'm going to do is I'm going to replace x squared with u. So this equation becomes u squared minus 29u plus 100 equals 0. What you should notice at this point is that our equation now looks like a quadratic, which means we can use normal, standard, reverse FOIL factoring techniques. The first positions I'm going to let be u and u. And I'm looking for two numbers that have a product of 100 and a sum of 29. Hopefully you recognize that would be 25 and 4. And to get a positive for the last term, while the middle term is negative, means both signs are going to have to be negative. So if I set these factors equal to 0 and solve, I would get u equals 4 or u equals 25. Now, the thing I have to remember here is u is really x squared, so I have to go back and substitute in, and that means I'd have x squared equals 4 or x squared equals 25. And in this form, probably the easiest way to solve this is using square roots, since I already have x squared by itself, and that means x is going to have to equal plus or minus 2, or x is going to have to equal plus or minus 5. So we just solved our quadratic equation, but this time we got 4 answers instead of 2 when we solved for x. But we used u as a way to help us solve for x because it made it look more like a quadratic. Moving down, I'm going to show you I could actually have solved this equation directly, and I could have just done reverse FOIL right off the bat. And if I notice that middle term's power, again, is half of the first term's, then what I can do is recognize that, and in the first positions, use x squared and x squared, and then put in the 25 and 4. Again, the order doesn't matter. I'll do it the same order I did above. To get a positive 100, while a 29, x squared being negative, I have to use both being minus. Now, I could, when I set these equal to 0, factor if I wanted, or I could use square roots. So I'm going to do both ways just to show you. Somebody might look at x squared minus 4 and say, oh, that is a difference of two squares, and that's going to factor into x plus 2 and x minus 2. Of course, x squared minus 25 would do that as well. And if that's your preference, that is fine. Or I could add 25 to both sides, like I did above, and then use the square root property. It's kind of up to you and whether or not you have to factor completely. And there are my 4 answers, which are both positive and negative 2 and positive and negative 5. All right, let's try our second example. This time we have x to the 5th minus 7x cubed plus 6x equals 0. What we have to recognize here is 3 is not half of 5. And there's a good reason for that, and that's the fact that we have a common factor of x that we can pull out of all 3 terms. And when I do that, that leaves me with x to the 4th minus 7x squared plus 6 equals 0. Now, I can look now and recognize the middle term's power of 2 is half of 4. So that means what's in parentheses is of quadratic form. So I'm going to go ahead and try reverse FOIL. I do have the common factor of x that I have to carry down. But in my first positions, I'm going to put x squared and x squared. And I am looking for 2 numbers that have a product of 6 and a sum of 7. That's going to be 6 and 1. And it looks like both signs are going to have to be negative so that the product is positive while the middle term is negative. At this point, we set each variable factor equal to 0. So we have x equals 0, x squared minus 6 equals 0, or x squared minus 1 equals 0. Some of you might be comfortable going to x squared equals 6. I didn't factor there because 6 is not a perfect square. You could make the case for x squared minus 1 if you really wanted to factor. I'm showing that to show you alternatives. For plus or minus 1, when you solve, you get plus or minus 1. For the x squared equals 6, since 6 is not a perfect square, we have to use square roots, but we don't want to forget plus or minus, and we just say plus or minus 6, or square root of 6. So I have 5 solutions. I have 0, plus or minus square root of 6, and plus or minus 1. So that was a polynomial of quadratic form, and we had a common factor that we had to pull out first before we could use quadratic techniques. My last example. This time I have m to the 4th minus 625. It's only 2 terms. It looks like a difference, but it's definitely not a difference of 2 cubes. I'm going to suggest it's a difference of 2 squares. You see, m squared could be squared. And if you know your perfect squares, 25 squared is 625. So I'm suggesting this is a difference of 2 squares. Some people might even suggest doing it that way, like using a u substitution. I'm just going to do a difference of 2 squares. And keep in mind that my first position, they're both going to have to be m squared. And the last, going to have to both be 25. And one's a sum and the other's a difference. This is the thing about something of higher degree that is a difference of 2 squares. I can't factor the sum of 2 squares, but I can factor the difference of 2 squares. So I'm not completely factored here. I would carry down m squared plus 25, but I'd have to understand that m squared minus 25 actually can factor again, if I want to factor completely. And now I'm factored completely. So setting each factor equal to 0, I obviously could have m squared plus 25 equals 0, meaning m squared equals negative 25. And I would have to use square roots here. And as I use square roots, because I'm taking the square root of a negative, I have to keep in mind I need an I with my answer. Of course, the other factors, when you set them equal to 0, again, you're probably comfortable with the fact that both of these are just going to give us m equals negative 5 or m equals positive 5. So we have 4 answers. Of course, our degree was 4, and that's the most you can have. But 2 of our zeros are not real, plus or minus 5i. 2 are real, positive or negative 5. Remember, the degree tells you how many zeros you can have altogether. They could all be real, or they could be a mix of real and imaginary. All right, your homework is on pages 346 to 349. You are doing numbers 30, 32, 42, 43, 46, 47. Then skip some pages, 74, and 89 is a graphing one. So you could use technology to help you if you wished. And if you want to get that one out of the way right away during class time, you could do that borrowing a calculator, but you need to make sure you sanitize it and put it back in the case. All right, thank you very much. Have a great day.